Okay, so in this video, I'm going to go through number 57 from page 430, asking us to find the vector v with the given magnitude in the same direction as vector u. I think there's 3 problems from the assignment in this little mini section. So just to back up a little bit, in general, to give some background here, a vector is, think of it as a graph, basically. I mean, that's kind of what it breaks down to. It can be used in physics to tell how far something is going and the direction. So it's got distance and direction. So our vector u, the component form is negative 3, 4. So that means I'm going to use negative 3 as my horizontal direction, go 3 spots to the left. 4 is my vertical direction, vertical distance, and so I'm going to go up 4. So I'm just plotting the point negative 3, 4, and then the vector itself starts at the origin, or goes from the origin to that point, and that is my vector. Now we put an arrow at the end to show that it's a vector, but it doesn't necessarily mean that it's continuing on past that point, like you would draw on a regular graph. It's just showing that this is a vector as opposed to some random line. So that's the vector u. We want our vector v to go in that same direction. It doesn't have to end at that same point. It could go past that point. It could be short of that point, but it needs to basically follow along that line and still start from the origin. So what we're going to do is we're going to reduce vector u down to a unit vector. To do that, we need to know the magnitude of u. We need to know how long this line is here from the origin to that point. On your formula sheet, we've got a lot of formulas for this chapter. The very first one is vector length. That's magnitude. That's exactly what that means. Now this sheet, when you were given this, you were told not to write any math on it. That's pretty much out the window. If you want to write notes on here now, you can. We're not, taking in-class tests or anything. I'm not checking to see that this is a clean piece of paper. So if you want to, underneath vector length, write magnitude, so you remember that those two things are the same, that might be a good idea. So we're going to use that formula. And what this is, it's basically the distance formula. You're squaring each component of your component form and adding them together and taking the square root. So we're going to find the magnitude of u. Magnitude is shown with the double lines. And if you notice here, for my vectors, I write this little arrow above. The book has the vectors in bold print. I can't really write in bold, so we do the little arrow over top to show that it's a vector. So magnitude of u is going to be the square root of negative 3 squared plus 4 squared, giving a square root 9 plus 16, square root 25. The magnitude of vector u is 5. Catching some of my shadows there from my phone. So magnitude of u is 5. So to get the unit vector in the same direction as u, unit vector meaning it has a magnitude of 1, we're going to take u and we're going to divide each one of those by 5. So let's call this, I don't know, let's call it t, I suppose. We'll call it vector t. That's going to be our unit vector in direction of u. And so that's going to be negative 3 over 5, 4 over 5. There's our unit vector. That is going in the same direction. So back to my graph here, I go over negative 3/5 and up 4/5 to make this little vector here. And that's the unit vector. That's going in the same direction, but it's only got a magnitude of 1. So now our goal is to write the vector v, which has a magnitude of 10. Right now, this has a magnitude of 1. To go from 1 to 10, we're going to multiply by 10. So we're going to take this new vector, this unit vector that we found, and we're going to multiply each one of these components by 10. So you could write it as an equation saying that vector v is going to be equal to 10 times vector t. 10 times that unit vector. So we're going to take each one of our components, multiply by 10. And that's going to give us negative 30 over 5. You could do some reducing here and cut out this step probably, but take my time. So then our final answer would be negative 6, comma 8. That's the vector v. It's got a magnitude of 10, and it's going in the same direction as vector u. So you would go out 6 and go up 8, and you can see that that would still be right along that same line, same direction. It's just got a longer magnitude. And so it's actually just twice as long, right? Our vector u had a magnitude of 5. You just double each of those components, and now all of a sudden you got a magnitude of 10. Now, not all the problems are going to be that straightforward, where you can just double both of the components, but it works out nicely in this problem. So again, that's page 430, number 57. I think you have to do 59 and 61. They should have a pretty similar process.